All right, we're live. Okay, finishing off 1.1. I didn't get this yesterday. How many people watch the video, by the way? How many hits did I get? All right, it's like a penny a hit, so it's awesome. And then sadly, third hour I got through less, so they had to actually watch more. So hopefully you pulled the YouTube to the end. It's easy to do, and then figure out where we missed. And just get used to it. It's right on the link calendar. It's expected if you're absent. Blah 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 blah. Okay, so it says locate each point in a coordinate system. This is going to be huge. This is going to be weird. This whole trigonometry, like you saw yesterday, is sticking an angle in a coordinate plane, and then you're going to deal with coordinates. So I call this coordinate plane trigonometry that we're going to do all the way to December, with the exception of a couple different chapters that don't do coordinate plane trig. So coordinates are going to be the key as well. That's great. I get this, what? But ask me again, and don't show me this. I always say don't show this again, and it always comes up. So, where's -3 located? All right, well, it's already here. -3 goes left 3, and then down 3. By the way, how does a coordinate go? X comma y or y comma x? What's the order? X comma y. So you know what? This is your introduction to what's going to happen to you this year. This is why you're going to get negative trig ratios. We said the sine of 30 is a half. I said you better have that memorized. Well, guess what the sine of 330 is? It's actually a negative a half, and it has to do with, and you don't know that yet, unless you were in honors, maybe you did, and it has to do with coordinates in coordinate plane trigonometry. So look at how this is constructed. This purple thing with this red line right here is called a what in geometry? Starts with a T. TR. Triangle. Okay, so that's a triangle. All right? And that's how you're going to do it. You're going to construct your triangles with x-coordinate movement, -3, y-coordinate movement, that happens to be -3 as well. And then you're going to jump back to the origin for the hypotenuse. Because when you move this way, left and down, this is a what kind of angle right here? For sure. Right. So this line back through here, we'll call the hypotenuse. We're actually going to call it something else. It's called an R value for radius. What has a radius? Circle. It's also unit circle. Unit circle trigonometry is something you'll see, or maybe some of you have. All right, so what would this R length be? Simple Pythagorean theorem, because it's a right triangle. Negative squared is, of course, a positive. So -3 squared is 9. Another -3 squared is 9. When you root 18, 18 is 9 times 2. What's the square root of 9, everybody? 3. You're going to find out, that's how a 3 pops out for radicals. You're going to find out that R value is always going to be considered a positive later in life. So that's what you do. Indicate with an arrow the angle in standard position, having least positive measure. So this is the angle starting from the positive x-axis to this terminal side that's created, or that terminal side that passes through this coordinate. Here is -3, -3. So looking at the directions, that's what you did. You're going to do this a million times this year. Coordinate trig, making a right triangle, terminal side passing through that, so on and so on and so forth. Okay, so that handles, I think, 117 in your homework. How many people did actually do that right? All right, so here's 1-2. You saw the section heading there? A lot of times I don't put page numbers on the calendar because I'm mean, but it's also because I shouldn't have to. If it says section 1-2, you turn to 1-2 and then you go to where the homework is. You can figure it out. All right? So the first thing is, what do you know about vertical angles? What do you know about vertical angles? All right, what do you know about this measure compared to this measure? Straight across from each other. What do you know? They're congruent. Hey, what do you know about these two measures from here to here? We already had that yesterday. What are those measures? What's the relationship between that? What is that measure right there that I put real big and obnoxious? 180. Supplementary 180. So no vertical angles are congruent, and then know that straight angles, two adjacent angles that make up a straight angle add up to 180. And then here's where we have to get this figured out. Parallel lines that lie in the same plane are cut by a transversal. We get a whole bunch of unique relationships. Like, first thing, what is 1 and 5 called in relation to each other? They're not adjacent. 1 and 5. It starts with a C. Come on. Corresponding. Who said that? Who said that? Raise your hand. Nice. 1 and 5 are corresponding. All right, don't write this down yet. I think I have it written down. What's 3 and 6? Ooh. 3 and 6 go across the transversal, so the word alternate, and then it's inside the parallel line. So 3 and 6 are alternate interior. What about 2 and 7? Excuse me. 2 and 7. Are they across the transversal compared to each other? So it's alternate exterior. What about 4 and 6? Do they alternate across? No, say they are on the what compared to the transversal? Same side. And what are they compared to the parallel lines? Interior. And then same side exterior would be like 2 and 8. And I don't know if I've missed anything. All right. Cheat. Look at that picture. What does it look like 6 and 3 are? Does it look like they're both acute? Does it look like they're both obtuse? One's acute, one's obtuse. What is the answer to that? They look like they're both what? Acute. So take a guess. Do you think 3 and 6 have the same measure? As long as the lines are parallel, you can put that in the bank. What about 2 and 8? Who do we appreciate? What's 2 look like? Acute or obtuse? Acute. What's 8 look like? Could they be equal then? No. What's the relationship though? They're supplementary. The reason is 2 and 4 are supplementary. And what's 4 compared to 8? What's 4 look like? Acute or obtuse? Obtuse. What's 8 look like? Obtuse. Those are corresponding angles. 4 and 8 are corresponding. They're equal. So since they're equal and 2 is supplementary to 4, 2 must be supplementary to 8. Those are little, rules and things that we've done in, geometry back in the day. So, okay, fine. Here's what we just covered. Alternate interior angles, like 4 and 5, they're congruent. Alternate exterior angles are congruent. This is only if the lines are parallel. And actually, that's what that symbol is that I added there. A third arrow on each of those sets of lines says they're parallel. As long as they're parallel, alternate exterior angles are congruent. Interior angles on the same side, those are not congruent because that 4 looks obtuse, that 6 looks acute. I could cheat on these and really get the relationships. I know there's a relationship. I forget which one it is. Cheat and actually what it looks like you can guarantee actually is. Not only same side interiors, I told you same side exterior. Add up to 180. And then, of course, corresponding. 2 and 6 both look acute, so they're equal. And they are corresponding. All right? I'll hold off on that for a second. What's the relationship in number 4 that I cut out of the book? What are these two angles? What are they called, by the way? Vertical. What do you know about vertical angles? They're congruent. So what do I do with these two expressions? Set them equal. And then I don't care. I'm going to do it. I swear to gosh, in this class, this CAT class I've taught for years, I still have students that can't handle an equation. I really don't know how you got this far. All right, but I am going to cover it as if you have not done this before. What should I do with this 37 to make my life easy? Add it. Whatever you do to one side, say it. People that can't solve an equation don't write this. They've been lazy their whole life, and then they don't know how to do it. What do I do to 7x then? Subtract. I'm a mathematics boy. I've been doing this forever. I still do whatever I do to one side, I do to the other, just to make sure I have balance. Make sure I've done the right thing to get everything on different sides. 5764 maybe? Hey, what does that mean x is? 16. Those are good numerate people. Okay? And then it actually says find the measure of each angle. So what should I do with that 16? Plug it in, plug it in. Could someone get a calculator for me? Better darn well get the same answer when you plug that in. Never trust a drawing. If these x's were here and here, these look acute. Don't, I know it's kind of bad what I said about, cheat on these, but never trust a drawing. If it said 33 degrees, but wait, that looks obtuse. Don't worry about it. That's, you know that about geometry. What do you know about number 12? What can you do with those two expressions? Set them equal y. What are they called? Alternate exterior, and alternate exterior angles are congruent. All right, now this one, fine. I'll go ahead and subtract the 6x from both sides. Boom. Subtract 61. Fumble. Is everyone okay back there? 112? Is that right? Never was good at math. And then divide by -4. 25 and then 4. 29? Is that 29? Wait. 28. I'm so ashamed of myself. Now it's on YouTube for billions to see. And what are you supposed to do that 28? I don't have the time. Plug it in. Let's move on. You know that. This is not what I should, this is a nice little refresher of what's going on. What do you know about these two? Supplementary. 2 and 3 are same side interior. This looks obtuse. This looks acute. Let's get this shindig over with. Now this one you add like terms. I've seen some bad things about solving equations here. You don't subtract 9x from the same side, so on and so forth. Plus 4 equals 180. And then 16x equals 176. Subtract 4. Being naughty by not doing my whatever I do to one side. I really shouldn't have to teach this at this point in stage of your mathematical careers. But what's that 176 divided by 16? I don't know that one. 11? Did you do that in your head? That's impressive. Most impressive. All right, and then you could plug it in. Actually, in this one I will plug in. What's 9 times 11? That's easy. 99 plus 9? 108. And then 7 times 11 is 77. 77 minus 5 is 72. And this meshes. These are supplementary. What does that make angle 4? What's that make angle 4? 108. Two reasons. The easiest one is it's corresponding to 2. And then what does that make 1? 108, because 108 is vertical to 2. Vertical angles are congruent. Or 1 and 4 are alternate exterior angles, which are congruent. Whatever. I love this. You know this. Angles in a triangle add up to what? 180. I love this because it's actually a nice little proof. I don't like 1 maybe so much because you may not see pictorially how you could cut up a triangle and fit it and make a straight angle. I kind of like the second one because it's based off of what we just used up there. So say you have a triangle. I'd put this down just for fun. Yeah, just do it. Just do it. All right? And then put the triangle so this side's on the bottom. And then draw a parallel line at the tip of the top of the triangle. And then this is a nifty little proof of why an angle, 3 angles in a triangle, add up to 180. Okay, so you have angle 1, 2, and 3. Now the reason I extended this line and put a parallel line through this point is I can snap angle 1's measure right here. Why? Because they represent what? What kind of angles is 1 and 1 here? Starts with an A. Alternate interior angles. So now that I extended this line up here and made this parallel to this line, angle measure 1 is here and also here. And then for the same reason, angle 2 is over here because this is an alternate interior angle situation as well. So if this is angle 2's measure, it is also up there. Erase that. And then, of course, we know that this all adds up to 180 because that's a straight angle. So I like that proof. I've never seen that before until I did this book. I just accepted that the sums of 3 angles in a triangle is 180. Nifty little proof. And then I'm not, I'm not writing this out. Actually, I don't even want to do this one. All right, so if we say we have three angles in a triangle that add up to 180, you just take the three expressions, add them up, and set it equal to 180 and solve for x, then plug them back in to find the angle measures. Same thing with this one. I'll just set it up. It's Mickey Mouse. I feel embarrassed that I'm even covering this with you because we should know this. That would be the setup. And then you solve and go from there. Is everyone okay? Acute triangle. Ah. All angles are less than 90. Right. 190. Obtuse. 1 obtuse. Equilateral, isosceles, scalene. So what do we call this triangle? What's 2 words that we could call this one right here? A right isosceles. So exciting. The one that you're really going to need me for is probably this. Maybe, maybe not. Concept number 5, and it's the last, I think, with some word problems. So we're getting through this pretty good. Give you a chance to work with your group mates. Okay, similar, not congruent triangles. And hopefully we remember this and know this. Of course, similar triangles don't have the same side measures. One triangle will be smaller than the other. But the angle measures is what makes them similar. So you get a bunch of nifty little properties off of that. A lot of yawners. I just wanted to wake you up right there. Inspire some life in you before we fall asleep. Sorry for the college, rote little thing. Maybe we'll do something fun Monday, and see what happens. So corresponding angles have the same measure, but the sides are proportional, right? So what does it mean to be proportional? Means that a set of fractions equal each other or are congruent to each other. So the angle measures themselves that correspond are congruent. Do be aware that if I say triangle ABC is similar to DEF, angle A is congruent to angle D, B is equal to E, C is equal to F. Okay, it's the order of the name of the triangles in the similarity statement that tell you who is equal to who. All right, but the sides are proportional, not equal. So write that down real quick if you need to, and I'll hold off. One little trick on this is if you're going small to big, your similarity statements should be small to big when you're setting up your proportion. AB small triangle corresponds with DE big triangle, congruent to BC small triangle over EF big triangle. Small to big is what I decided. You could flip all the fractions as well. I think we know this. So Mickey Mouse, actually no, this is a little bit tougher. Name the corresponding angles and the corresponding sides of each pair of similar triangles. Wow. Okay, first of all, what do I call this angle measure? Can I call it angle G? Yes or no? No! Sorry for those that said yes. Because angle G is a vertex for how many angles, really? It's actually, you could argue 4 or you could argue 6 because there's 2 straight angles in there. So if angle G is a vertex for multiple angles, you can't just say angle G. So what's the name of this angle? Yeah, go ahead, sir. HGK. Who is HGK congruent to? EGF or FGE? Now that starts the ball rolling. Who is angle H equal to according to this parallel statement that this line is parallel to this line or that segment? Who's angle H parallel to then? I'm sorry, congruent to. It is F. Why? Starts with an A. Alternate interior angles theorem. Okay? These are alternate interior angles. H, these are the 2 parallel lines cut by this transversal. So F is an alternate interior angle to H. Then, of course, that gives you K and E. All right? And it's the same reason. Now what we need to do is maybe write write a similarity statement for the sides. Maybe do it as a proportion. Who does HG go with? So if I went small to big, HG over, who does HG correspond to? Well, the answer is the side that touches these same two angle measures, the 1 and the 2 mark side. Who is that? What side is that in this triangle? It's FG or GF. And that would be congruent to, actually I should put these symbols on here. I could use equal when I don't use the symbols on the situation. This means the length of HG, so I'll get rid of that. I'm kind of going over some things in my mind, little semantics about geometry. Then, of course, HK. Who does HK go with? That's easy. EF or FE, doesn't matter. Then that equals the leftover, KG. Hey, Kelvin Grove. And then GE. Hey, we bring good things to life. Nobody? Nothing. This one's stupid because it's easy. Who does A go with? Who does A correspond to? 10. So it's A over 10 equals. You know, you don't do B. You want to do what's given. So 75. Who's 75 go with? 25. And then how do you solve for A? Cross multiply. You get 25A equals 750, and then you move on. You're going to use all these skills throughout the year. They're going to be demanded that you know this. Everyone looks so sad. All right, and then the same thing with B. Who's B go with? B over 20, and that equals, same thing, 75 over 25, cross multiply, you may get a decimal. Now, two more that you might need me for is actually this one. What they should actually tell you is that these are parallel, and then we can do what we're going to do. But I guess it's assumed. Don't assume a right angle here, only if it's marked. Should you assume that? Okay, what we have to do is find C. What you need to understand in this one is this, and I'd write this one down because this is where it gets tricky. And then the 1-2 ago where you had the triangles connected, top and below each other. Boom, 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 compared to boom, boom, boom. Now you gotta hold this off. Why are those two triangles similar, first of all? Well, if these two lines are parallel, what kind of angles are these? That one and that one. Don't say right! They're corresponding. And when the lines are parallel, cut by a transversal, corresponding angles are congruent. Why are these two angles congruent? Huh? Why are those two angles congruent? Say the same thing! Corresponding angles. Mark, 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 mark. The yellow and the blue are now similar by AA. Actually, it's AAA, but they stop at AA. But the third angle right here is shared by both triangles. So, of course, that angle is equal to itself. Did you guys do proofs last year? Did you do any proofs, like paragraph proofs, or did you? 2 years ago? Oh, yeah, you probably shut that out. Went to counseling after that year and then got it all wiped out of your mind. All right? So, what does 90, and actually it might be helpful to do this. Yank both triangles out. Like, just to fumble, and then make sure that you understand the yellow. What's the yellow's? What's the yellow's, yellow? What's the yellow? What's the yellow? What are the lengths for the yellow? That's easy. What's this bottom length? Say it! 90. What's this top length? Hundo. Okay, and then the blue one. Now this gets crazy. But you're going to maybe want to do this at some point and understand that you might want to yank these two out and separate them. What's the bottom blue's length? Hundo. And then what's the top length here? Oh, that's not 90. Oh, we're getting a whole bunch of different answers. This is fun. 110? Nobody got it right yet. Not 112. What is happening? It's 100. Oh, I'm a maroon. It's actually just C. Did anyone say C? No one said C. Who said C? We didn't say it loud enough. Okay, so fine. It's okay. Hey, the only thing that was tricky is maybe that hundo. So fine. I'll move on. Everyone's turned it against me. 100 over 90 equals C over a hundo. And then cross multiply and solve. Got it? All right, and then try to draw this last one. And then we'll leave you alone. Do it! Who just said that? Okay, I'm done with my drawing. Here's how it should look. Boom! Isn't that nice? Thank you. Yeah, I've worked really hard on that. Actually, I did years ago cut all these pictures off a Word, I think, or something. Here's the idea, though. The sun obviously is, what is it, 93 million miles away, I think? That number's in my head. It comes from this book. We have a book, a lot of cool book questions later about the planets and Earth and spinning around and stuff. But the sun's so far away that the shadow on the lighthouse and the shadow on the truck creates a similar triangle relationship because the angle, even though this is taller, the angle that it hits each one of them, since it's so far away, is exactly the same. That top angle is, congruent to that top angle on the truck as far as the angle the sun's hitting us. And then we're going to assume, you should never really assume anything, but we're going to assume that they're on flat ground, so there's a 90-degree angle there. So by AA, the shadow relationship's a similar triangle. So and you could do this outside. You could know your height, you can measure your height, you can measure your shadow, then you can measure the shadow of a building, and by a similar triangle relationship, you can find the height of the building, just like that. Snap, snap. Okay? So anyway, the shadow's 180 feet, which is tough to draw. The height of the truck and length of the shadow. Shadow's on the ground. Heard some people asking, where is the shadow at? X over 9 then would work. That equals, I went big to small, 180 over 15. Right? And then you cross multiply and solve. What'd you get for an answer? 108. So it's 108 feet high. I'm done. Okay, so fun stuff. Hopefully you got that right. And sorry if I bored you.